Hi everyone! Welcome to part 1 of the SOH CAH TOA lesson. Here's today's FLT. Given a right triangle, I will be able to apply trigonometric, or trig, ratios in order to find the length of the missing sides. So for these upcoming lessons, we'll be looking at these things called trig ratios to help us find missing sides or angles of right triangles. So throughout the past few lessons, we've been looking at how to find side lengths of right triangles. When you're given two sides of a right triangle, you can use the Pythagorean theorem to find the third. And that involved the formula a squared plus b squared equals c squared. We also looked at special right triangles, specifically the 45-45-90 triangle and the 30-60-90 triangle, which helps us find missing side lengths when we're given one side and a special angle. But what if you're just given one side and one non-special angle? So what if you have a non-special right triangle? This is where we start using trig ratios. To start looking at trig ratios, let's look at this right triangle right here. I have triangle ABC. And let's draw a person here at angle A. We're going to look at each of the sides based on where this person is standing. We know that the side right across from the right angle is always called the hypotenuse. So here we have the hypotenuse, and then the side on the opposite of the person is called the opposite side. And then the side right next to our person is called the adjacent side. Adjacent means being right next to. So here we have the adjacent side. So here we have the hypotenuse as well as the opposite side and the adjacent side. Think about how the opposite and adjacent sides would change depending on where our person is standing. For example, what would the opposite and adjacent sides be if the person was standing at angle B? Alright, so now let's look at this acronym, SOH CAH TOA. You may have heard this before, but don't worry if you haven't. What does SOH CAH TOA even stand for? So the S, C, and T each stand for sine, cosine, and tangent. Sine, cosine, and tangent are trig functions. I like to think of them as tools to help us find missing angles and sides of triangles. On your calculator, you'll only notice the first three letters of each function. So for example, for sine, you'll just see SIN. O stands for opposite, so the opposite side of where you're standing from. Notice how the opposite side is associated with both the sine and the tangent parts. A stands for adjacent. It's that side right next to you in the right triangle. So adjacent sides are associated with either cosine or tangent functions. And H stands for hypotenuse. This is the side opposite of the right angle. So the hypotenuse is associated with the sine and cosine functions. So we've looked at what the acronym stands for. Next, let's apply it back to our triangle from earlier. So here's the acronym SOH CAH TOA, along with the triangle from earlier where our person is standing at angle A. And we're going to write out some trig ratios based on the acronym SOH CAH TOA. So the SO part, the first part, tells us that the sine of A equals the opposite side, because of that O, over the hypotenuse, the H. So that's our first trig ratio. And let's look at the second one. So CAH tells us that the cosine of A equals the adjacent side over the hypotenuse. And then we have our last trig ratio. The tangent of A equals the opposite side over the adjacent side. And these trig ratios are tools to help us find missing sides or missing angles. In this lesson, we're focusing on how this helps us find missing sides. One thing to notice is that this part right here, this depends on where you're standing. So at which angle are you standing? So it's always going to have the format sine of something, an angle, but you're not allowed to leave it blank. It's always going to be sine of a certain angle. And to denote that angle, in general, we use this theta mark right here. And this theta represents some kind of angle. It's the angle we're standing at. So we're going to be looking at 5 different examples today. And each example is split into part A and part B. So what we're going to do is look at part A of all 5 examples first, and then move on to part B of all the examples. So in part A, we're going to be given a right triangle, and we're going to set up a trig ratio to solve for x. But we're not necessarily going to solve for x yet. We'll do that in part B. We're given our first example here. It tells us to set up a trig ratio to solve for x. I have a right triangle with one given angle as well as one given side, and I have to find that x side. So let's draw a person at where the given angle is at. So here I have my person at the 34-degree angle, and then based on where this person is standing, let's identify which sides we're going to be working with. The hypotenuse is given. The length is 3.6. And the opposite side is the unknown side length we're looking for. The adjacent side is blank, so we're not even going to look at that. I have my acronym, SOH CAH TOA, and I want you to think about which part includes the opposite side and the hypotenuse. So in which part do you see an O and an H? So I noticed that the first one, the sine portion, includes the O and the H. So I'm going to set up a trig ratio using this part. The sine of 34 degrees equals the opposite side over the hypotenuse. In this example, the opposite side is x, and the hypotenuse is 3.6. So we were able to set up a trig ratio based on the given right triangle. We use the sine portion of SOH CAH TOA since we're focusing on the opposite side and the hypotenuse. Here's part A of example 2. I have a different right triangle here. Again, we are going to set up a trig ratio to solve for x. I draw my person here at the given angle, and I identify the sides. So here's our hypotenuse and our opposite side. Once again, we are not given an adjacent side, so we're focusing on where we see an opposite and a hypotenuse, which would be this first part, the sine function. So I have that the sine of 62 degrees is, again, it's the opposite over the hypotenuse. For this example, the opposite side is 2.7 and the hypotenuse is x. So we have that the sine of 62 degrees equals 2.7 over x. And in part B, we'll be using this trig ratio to solve for the side length x. Let's look at part A of example 3 here. As I've mentioned in earlier lessons, just try your best to draw your most accurate sketch of the given right triangle. I draw my person at this given angle, and based on where this person is looking, which sides are we working with for this example? We're given the opposite side as well as the adjacent side. So which trig function can we use when we're working with the opposite side and the adjacent side? Tangent, this third one right here. So I can set up a ratio, the tangent of 53 degrees equals, so the opposite side over the adjacent side, which is 12, the opposite side, over x, the adjacent side. Notice here, we're using a different trig function from the earlier examples. We're using the tangent function since we're working with the opposite side and the adjacent side. Here's example 4, part A. Let's draw a person at the given angle and see which sides we're working with. So we're given the hypotenuse, and then we're also working with the adjacent side, the side right next to the person. So which trig ratio would we set up here? We're working with the adjacent side and the hypotenuse. In this case, we would use the cosine function. So let's set up a trig ratio. The cosine of 42 degrees, the given angle, equals the adjacent side over the hypotenuse. The adjacent side is x, and the hypotenuse is 14. So for this example, we set up a trig ratio using the cosine function. And here's example 5, part A. Go ahead and try setting up the trig ratio on your own, and then press play when you're ready. We're given this angle right here, so let's draw a person here. Based on this person, we're working with the opposite side and the adjacent side. So we're going to be working with the tangent function. So let's set up our trig ratio. The tangent of 13 degrees equals the opposite side over the adjacent side. And that's x over 2.4 for this triangle. So here we have a trig ratio using the tangent function. Now, before we go on to part B of all 5 examples, I did want to quickly talk a little bit about calculators. On the left side, we have a phone calculator, And if you have an iPhone, you can get this by turning your screen to the side. And on the right, you have the scientific calculator. So maybe you have one of these at home. If not, don't worry. So if you're using the iPhone calculator, at the bottom left, it's probably going to say RAD, which stands for radian, and you actually want to keep it here. If it says degree, click on it again so that it switches back to radian. It's a little confusing, but the current screen shows that the calculator is on degree mode, and then if you happen to click on the rad sign, then it switches to radian. And that's not a mode we're looking at yet. Today we're just focusing on the degree mode. And then if you're working with the scientific calculator, at the top there's like a DRG symbol. So keep clicking on that until you see degree show up somewhere on your calculator screen. But if you don't have either, don't worry. You can go to desmos.com/scientific, and there's a calculator there that's really easy to use. I personally really like using the Desmos calculator, so I'll be using it for the upcoming examples as well. So we're back to example 1, but now we're on part B. We're actually going to find x to the nearest tenth. So earlier in part A, we set up the trig ratio. Sine of 34 degrees equals x over 3.6. And we're going to solve for x to find that missing side length. To isolate x, we're going to multiply both sides by 3.6. That way, this cancels out, and we are left with 3.6 times the sine of 34 degrees equals x. So let me write that the other way around. X equals 3.6 times sine of 34 degrees. And from here, you're going to be using your calculator. So if you're using the Desmos calculator or a scientific calculator, simply type in 3.6 and then sine of 34 degrees. You just put sine 34. And then you get the answer on the right side. If you're using the iPhone, you kind of have to go backwards. So first you type in 34, then click on sine times 3.6. So instead of typing in sine of something, you put in that number first, the degree first, and then click on sine. All right, so for x, we got 2.01309 ... But notice how we're asked to just round to the nearest tenth. That's the 10th place right there. We look at the digit right under it. In this case, we do not round up. So the answer is simply 2.0. We were able to find x using the idea of trig ratios. So here's part B of example 2. Earlier, we set up the trig ratio. Sine of 62 degrees equals 2.7 over x. I'll go over the mathematical way of solving for x first, and then go over a shortcut. So first, we're going to multiply x on both sides so that it's not a denominator. This cancels out, and I have x times the sine of 62 degrees equals 2.7. And to isolate x, next I divide both sides by sine of 62 degrees. So I find that x equals, oh yeah, and that cancels out. So x equals 2.7 over sine of 62 degrees. And let's put this in the calculator. So if you're using a scientific calculator or the Desmos calculator, just type 2.7 divided by sine of 62, and your answer shows up on the right side. And if you're using an iPhone, again, it's a little bit backwards. So 2.7 divided by, and then you're going to do 62. Click on sine, and then you're not done yet. Click on equal to get the final answer. So we were able to find this value, x equals 3.0579 ... but we're only rounding to the nearest tenth. In this case, notice how we have to round up. So x is approximately 3.1. And then here's the shortcut that I was going to mention. So we had this trig ratio, right? If you see x in the denominator, all you have to do is switch things up a little bit. So x equals 2.7 over sine of 62 degrees. So we switch the sine of 62 degrees and the x. Again, this is just a little shortcut that you can use. All right, so let's look at part B of example 3. We had the trig ratio, the tangent of 53 degrees equals 12 over x. I'm just going to use the shortcut here. So I switch things up, and I get that x equals 12 over the tangent of 53 degrees. And I plug this into the calculator and get 9.0426, and it keeps going, but we're rounding to the nearest tenth. So x is approximately 9.0. Let's look at part B for example 4. We had the trig ratio cosine of 42 degrees equals x over 14. Here, to solve for x, we just multiply by 14 on both sides. This part cancels out, so x is isolated. We have x equals 14 times the cosine of 42 degrees. And when you plug it into the calculator, you get 10.404, and it keeps going. And rounded to the nearest tenth, we have that x is approximately 10.4. So here we use the cosine function to find the missing side length x. And here's our last example. So part B of example 5, we had that the tangent of 13 degrees equals x over 2.4. To solve for x, we multiply by 2.4 on both sides. And this cancels out, this part right here. So we have that x equals 2.4 times the tangent of 13 degrees. Plug it into the calculator, we get 0.55408. It just keeps going on. But rounded to the nearest tenth, x is approximately 0.6, since we're rounding up in this case. So for these examples, we first set up trig ratios based on which sides we're working with. And then once we set up the ratio, we solved for x to find the missing side length. So as a review for today's lesson, think of sine, cosine, and tangent as tools to find missing sides of right angles when you're given one side and one angle. Remember the acronym SOH CAH TOA, where S stands for sine, C for cosine, and T for tangent. And A stands for the adjacent side, O the opposite side, and H the hypotenuse. Great work today, and please remember to submit your notes on Canvas. Thank you.